Here, are you familiar with any of the any form of graph technology, as in graph analytics, knowledge graphs, graph ML? Yeah, fantastic. That's good. So that's good, and I hope that you're not only familiar with it, but also using it. Because if you're not, I would tell you that you will be giving up 50% of the value of your data, and that's quite simple. And you will be doing that because you will be ignoring a critical aspect in your data, which is the relationships between data points. The relationships as in the connections between records in your data warehouse or documents in your document database. At Neo4j, we believe that these relationships are as important, if not more, than the data points themselves. And we believe that because you get three things out of them. And let me see if the clicker works here. Looks like maybe I got the wrong clicker here. Well, we'll get there anyway. So the first thing that you get from relationships, obviously, is that they bridge siloed data. They connect the dots. They literally, that's last slide. So the first one, so they bridge siloed data, and by linking siloed data, we make it queryable, we make it navigable, we make it effectively actionable, and therefore we can get value out of it. The second thing that you get is graphs, as we're going to see. I'm going to spend part of my presentation talking about that, enhance this new way of accessing data, new because it's the one that agents use, which is retrieval, right? I'm sure you've heard, unless you've been living under a rock over the last couple of years, RAG, right? Retrieval augmented generation. So retrieval is the way in which agents access your enterprise data to ground their actions and the responses. So we're going to see that how graphs enhance and augment the way in which that happens. And the third one is particularly important, and is the fact that graphs, when analyzed at scale, they reveal patterns in your data that are extremely insightful and valuable for you. And patterns are nothing but shapes, right? Let me give you some. It's the kind of the latent structure in your data. Let me give you a few examples. So if you're in the finance space, a shape can be a ring, right? A ring might be a sequence of consecutive transactions, as in money transfers between accounts, starting and terminating at the same account, and maybe that's hiding some form of money laundering scheme. Another shape can be a star, right? Let's say now you're in the energy, telecom space. When you're modeling dependencies between devices, between components in your system, and a star can be formed by chains of dependencies converging into a single element. If that element goes down, the impact to your overall system is going to be significant. So you want to be aware of that. So that star shape is an important one. There's other shapes like chains, right? Chains are, if you're doing risk analysis, ultimate beneficial ownership. Following a chain of dependencies will help you uncover hidden indirect dependencies between elements, right? It's important in things like supply chain, finding bottlenecks in your supply chain. It's in the name, right? Chain is a shape. There you go. So these type of shapes, like rings, stars, clouds, chains, none of the existing systems in your data architecture are going to help you surfacing those. So a fundamentally new approach is needed, and that's exactly what graphs provide, right? But let's put this in the context of AI. And I started my talk with this idea of context graphs, which is the most recent iteration of this wide consensus that AI, LLMs, need knowledge graphs to ground their actions, their decisions. So we need to kind of counterbalance this kind of creative angle, these reasoning capabilities of LLMs, with some controlled, curated, trusted data that comes from knowledge graphs, right? So that's, and this materializes, this happens through this architecture that's called graph RAG. I won't go into too much detail because I'm sure you've seen that many times, but this is the standard flow of agents, right? So we see the agent at the center. If you follow the numbers, the operation starts with a task, with a query, right? The query gets the agent into this loop of planning, retrieving. It will get access to your enterprise data, and it will get to a point where it's ready to produce an output. Now, the thing is, this access to enterprise data, as you can see there, materializes through a number of tools. And here's what graphs make a massive difference, because what graphs make sure, and this idea of graph RAG, is that we offer the richest collection of retrieval strategies that are available for you. So you can see that we combine things like any other data store text to structured query. In our case, we have our own query language called Cypher, which is a pattern-based query language, equivalent to SQL in a number of ways, but bringing this idea of patterns in your queries. But we can also do vector search and combine that with contextualization based on navigation of the graph. And that's where, by offering a rich collection of retrieval strategies, we make sure that your agents get the most out of your data. And in this is what we tend to call making your data AI ready. Good. So now, why, you ask yourself, what's the benefit for me of doing that? Well, you get three main benefits. The first one is accuracy and precision, right? I will add to that the idea of explainability. We're going to get into that in a moment. But the second one is also ease of development and governance. So let's go into each one of those. So the first one, I entirely delegated to third-party benchmarks. So you have the links there. I won't go into too much details, but these are organizations like LinkedIn, like ServiceNow, like Letria. You have a number of others, Writer as well, that have quantified, basically, what's the impact to accuracy that putting a knowledge graph and implementing GraphRag compared to just plain vector-based retrieval. Right? And you see the numbers. So first one would be improved precision and accuracy. The second one, we said ease of development, and that basically will translate in shorter time to solution, shorter time to production, cheaper maintenance, because basically your data engineers are going to feel a lot more comfortable dealing with this symbolic representation, explicit representation in the form of a graph. We have a simple example here, like if we want to express something like apples and oranges are both fruits, in a graph representation that would look something like two nodes saying, well, both apples and oranges are subcategories of a fruit, right? That's sort of a taxonomical representation in the form of a graph. You can also capture that in the form of a vector, which is the kind of sub-symbolic, like the neural system's approach to that. The thing is, this is a vector, which is a numeric representation of the same thing that will magically happen to be semantically close and in proximity, and we can do this kind of a semantic search, as we call it. The main difference is that the one to the left is something that as a human I can understand and I can explain. The one to the right, it happens to work, but it's harder for explainability. But it definitely simplifies the process of development and construction of solutions based on these type of technologies. And finally, the third one is particularly important, which is governance. And one aspect of governance is access control. Right? Trying to impose any kind of access control on vector-based systems is not very practical. It's actually impossible. Whereas in a knowledge graph, we introduce a fine-grained access control model based on the schema. So you can be very specific about who can access to, and by who is which agents can access what part of the information. And if you're in the medical space or in a highly regulated industry, being able to control that is extremely, extremely important. So this is the third element of value. Good. So these materialize from an architectural point of view in what we call the knowledge layer, the semantic layer, which is this kind of standard, unifying layer that sits on top of your data, and that provides a unified view, consistent and semantically enriched, of all your enterprise data. And that includes, ontology, that includes all forms of agentic memory, episodic, semantic, temporal, procedural, and giving a consistent perspective to agents and any kind of consumer applications. You might be asking yourself, but you've been talking about databases. Does that mean that I have to replicate all my data to get these benefits? Well, the answer is not necessarily. It's a spectrum, right? And depending on your use case, depending on your case, you will determine how much of that data stays at the underlying platforms, and therefore the knowledge layer just captures the metadata, right? And metadata plus reference data plus dimension data, and in some cases you will move parts of the actual instance data into the graph, but it's a spectrum, like I was saying, and depending on the case, you will determine how much of that makes it into the graph and how stays and is accessed on demand. So that's the idea. Now, in the interest of time, well, just as an example, we have a great customer, which is one of the top 5 gaming companies that have implemented that. I've stolen literally a diagram that's, I don't know if it's very readable, but it's a simplified version exactly of what I showed before. So you have a number of agents that sit on top of this semantic layer that they've implemented on Neo4j that basically provides access to multiple enterprise systems. And you see some of the benefits that they've, in terms of reduction in the time to get insights from their data, and the speed and the number of users that they have on top of this platform. Now, like I said at the beginning, I wanted to talk a little bit about context graphs, and I've share with you some of the pointers. The conversation started by this foundation capital, this investors, and they presented it nothing less as AI's $1 trillion opportunity, right? But the idea behind this is that there's the need for a system of record for decisions, not just for data. The concept is simple, right? So if you go to your CRMs, to your ERPs, to your enterprise systems, you're going to be able to say that that deal was sold with a 20% discount. But you won't be able to tell what was the process, the decision that led your organization to provide this level of discount. If one of your customers has a certain credit limit, you will have that in your systems, but you will not capture, you won't be able to answer how did that happen, how, which kind of reasoning took place behind the scenes to get to that point, to get that state of affairs. And the reason for that is that this information is scattered, is lost, is probably partially in Slack conversations, it might be in call transcripts, it might be in all sorts of enterprise systems, but it's really hard to operationalize and action now with the presence of agents. Oops, that's back to the. So this we have the possibility of tracing the execution of agents and capturing all these elements of information. And guess what? Well, that's the reasoning, the precedence, the causal chain, the context, etc., etc. I was saying that looks very much like a graph, doesn't it? So that's exactly the proposition, right? The idea of, and why they called it a context graph. So we've built a demonstration of this, and which I'd love to share with you if you come talk to us at our booth there. But it looks something like that. So this is the graph that captures, I don't know if it's readable, but you see the entities that where it combines the domain information. This is in the context, like I was mentioning before, of an individual getting a particular credit limit increase, right? So we have information about persons, accounts, transactions, organizations, but at the same time, we link that to things like to elements of the decision trace, which is decisions, decision context, exceptions, escalations, community, and all this information is connected through relationships in the graph. I kind of cut that there because I didn't have space in the slide, but it's the kind of things, these relationships are natural in graph, but a nightmare to represent in relational systems, in SQL. So this is the way we would capture in a knowledge graph the context, or the context graph, which from our point of view is just a new form of knowledge graph that has as objective capturing this kind of the why of these type of processes. And well, like I say, if you want to have a look, we have a live demo where you can check what that looks like. But I would love to share that to you, and show that to you at our booth if you come talk to us afterwards. But that's pretty much what I had. So a few takeaways of my talk. I don't have a timer, so I don't know if I'm good for time or if we're still past. But the first one is that AI needs structured context, and that's what graphs bring. That's the main idea. Then the implementation, graph RAG, turns the retrieval process into a reliable and explainable system. And not only that, I talked about memory before, procedural memory, context graphs. So graphs are really the substrate of all this AI knowledge layer that I was talking about. And finally, that's a given, but it's extremely important. The traceability, governance, and trust has to be built in by design in the solutions that you create. And that's what you get from graph-based implementations. So that's it. A couple of learning resources, 2 books that I've been co-authoring with some colleagues that you can download from the O'Reilly website. And with that, thank you very much. I don't know if I have time for questions, or I'll continue there. Thank you.
Thank you so much, Jesus. One more time for Jesus, everybody. Thank you.